Now coming to the summary. Chemical kinetics is the study of chemical reactions with respect to reaction rates, effect of various variables, rearrangement of atoms and formation of intermediates. The rate of a reaction is concerned with decrease in concentration of reactants or increase in concentration of products per unit time. It can be expressed as instantaneous rate at a particular instant of time and average rate over a large interval of time. A number of factors such as temperature, concentration of reactants, catalyst affect the rate of a reaction. Mathematical representation of rate of a reaction is given by rate law. It has to be determined experimentally and cannot be predicted. Order of a reaction with respect to a reactant is the power of its concentration which appear in the rate law equation. The order of a reaction is the sum of all such powers of concentration of terms for different reactants. The rate constant is the proportionality factor in the rate law. Rate constant and order of a reaction can be determined from rate law or its integrated rate equation. Molecularity is defined for an elementary reaction. Its values are limited from 1 to 3, whereas order can be 0, 1, 2, 3, or even a fraction. Molecularity and order of an elementary reaction are same. Temperature dependence of rate constant is described by Arrhenius equation. K equals to A e की power minus EA upon RT, where EA corresponds to the activation energy and is given by the energy difference between activated complex and the reactant molecule, and A corresponds to the collision frequency. Arrhenius factor is also known as pre-exponential factor. The equation clearly shows that with increase of temperature or lowering of EA will lead to an increase in the rate of reaction, and presence of a catalyst lowers the activation energy by providing an alternate path for the reaction. According to collision theory, another factor P, called steric factor, which refers to the orientation of molecules which collide, is important and contributes to effective collision. Thus, modifying the Arrhenius equation to K equals to P times ZAB e की power minus EA upon RT. Integral rate law for zero order reaction is given by A0 minus AT equals to KT. Integral rate law for first order reaction is given by AT equals to A0 e की power minus KT. Half-life, that is T-half, for zero and first order reaction is given by A0 upon 2K and ln2 upon K respectively. Unit of rate constant is given by mole to the power 1 minus n, L to the power 1 minus n, and S to the power minus 1, where n is order of reaction.